Good morning or afternoon, depending on when you are watching this video. This is CS222, Group 69, and our Project Snake Study Game, a productive way to have fun. The developers on this project include me, Edith Zhan, and I worked on game mechanisms and refactoring. There's Meyer, who worked on snake movement and timer functions, Mekenna Gibson, who worked on snake mechanisms and sound design, and Holika Nanna, who worked on page navigation and UI design. Now, why did we choose this project? To begin with, doom scrolling is a very large problem that many of us face. We take a short break on social media, hoping to get away from our schoolwork, and the short break quickly turns into a 5, 10-hour-long endeavor in which we wish we could have done something productive. And so we've turned to a study timer app that uses Snake. The reason why we choose the game of Snake as opposed to other different games and alternative study timers is that it is a low effort but still brain active game, which keeps you engaged. We chose to do this, to do our Snake game through a Unity application, in which the user can set the duration of the timer. Now then, let's move on to our tech demo.
I am on the main menu here. Let me run that. So as you can see, we have 4 buttons here that all implement CodeMonkey utils. We have the setup button, the play button, how to play, and quit. So let's start with how to play here. So how to play is just something we implemented in the case that anyone is unfamiliar with the game of Snake. This back button here uses CodeMonkey utils as well. Let me press that, and it takes us back to the main menu. If I click on setup here, it's going to take us to a screen that helps us set up the timer that we want to implement for the purpose of making the game of Snake across the study timer aspect. So let's say I press go here. Since we haven't input any actual values yet, it's going to tell us input string was not in the correct format. This is just indicating to us, right, that we need to put in some integer values. So let's say for study time, just for the purpose of the demo, I'll put 1 minute, and for playing Snake, 2 minutes. So if I press go now, it's actually going to take us to the study screen, or the game screen, sorry. On the left, you can see that there is the score tally and the current score in the blue box. The timer is at the top. As you can see, it is continuing to count down. We also implemented a pause menu, so if I press escape here, it's going to show us the pause screen, and we can either resume or go back to the main menu. So at this moment, let me return to the main menu. Takes us back to all of this, and everything is still clickable. If I press play again, it is going to reset that time to 1 minute for the study timer, which you can't see yet, and 2 minutes for the game time. If I press pause again, and if I press resume, it's going to continue the time, right? Those 10 seconds are not regained. So now, as you can see, we are using our own UI, the apple we've created, the background we created, even the snake. So all of this stuff was created by me, Holika, through Adobe Sketchbook, and that's just what we're using throughout our game here. So now let me start eating this fruit. So as you can hear, we have implemented a little sound every time you eat the apple, and also when you hit the edge, there is a failure sound. This is the game over screen. It shows you your current high score and the score for this round. And if you press retry, it's not going to reset that game timer. So give me that minute here to beat my current high score. And of course, as you can see, as I continue to eat the fruit, the snake grows. All right, so now I've beat my high score. We can see that if I also run into the body of the snake, the game will be over as well. And we have this high score screen. The timer is still counting down. It updates the new high score, and it still showcases that current high score. So if we let the timer run out here, it will switch over to the study timer screen. All right, so now you can see that the study timer is counting down from that 1 minute we set, and it's just going to keep counting down, and eventually it will switch back over to the game screen. So let us wait the 1 minute for that. But as it approaches the time to switch back, you will now see that once it gets back to the game screen, it is back to that 2 minutes. So let me showcase the exit button really quick. Let me reset this where it's 1 minute for each. So let me let this game run for 1 more minute so we can get back to the study timer so I can showcase the exit button. Alright, so now we will switch over here, and like I said, if I click the exit button, we will go back to the main menu. And finally, if I click the quit button, it will quit the application, and that is it.
All right, moving on to the architecture behind everything in the demo that you just saw. So we launch into the main menu. There are 4 buttons. There's a setup button, how to play, the play button, and the quit button. The most simple one is the how to button, as Holika showed in her demo. Takes us to a screen that explains how Snake works for those who are unfamiliar. The quit button will exit the application entirely. The how to and play buttons will both get us to the gameplay section. However, the setup is what allows us to get to the timer setup screen, where you can use user input on the keyboard to type in the number of minutes you want to study versus the number of minutes you want to play the game. Once that is input, we press go on the screen and it takes us into the gameplay. In the gameplay, the user will use the arrow keys to navigate the snake around to his apples, and there's also the pause menu that is accessible through the escape button, which allows us to track back to the main menu or resume playing our game. With the study timer set up, the timer is responsible of cycling between gameplay and the study screen until the user kicks it out of there. When the timer on the gameplay runs out, we get moved over to the study screen timer, which just counts back down and goes right back to the gameplay. So that's for that page. So for all of these scenes and scripts and wonderful things in our library, we used Unity for everything. We used GitHub to keep track of everything in a repository, and we coded this project in C#, using VS Code as our place to keep track of all of that. For our how-to screen, Holika worked on that. The Text Mesh Pro from Unity's registry was also used for UI elements. Our main menu was also done by Holika and is using similar libraries, including the CodeMonkey utils. Timer setup was done by Lily, as well as the timer. Then the next one, we have the gameplay is where a lot of stuff's going on in our project. We've got the snake, we've got the food, all the good stuff's there. In addition to all the resources I mentioned on the last slide, we also used Canva and Adobe Sketchbook to create sprites and design elements of the UI, and Flat, which is a music composition software used for the sound effects in the game. Inside of here, Mekenna, was responsible for snake growth as well as the sound and music. Edith took care of the movement, UI, death of the snake, score, and the food. Holika took care of the sprites, the high score, more UI, and the pause menu, and Lily worked on movement in this scene. Our quit button was also created by Holika, and the study screen is and thanks to Lily's hard work.
So during development, we faced two major challenges that I will go through in the following slides. The first challenge was that we were working with a completely new development platform. We did not know how to use Unity. We all had zero experience with Unity, but a willingness to learn. So we dealt with the novelty of Unity through three means that I'll go over, the first being video tutorials. Throughout the project, we referenced the CodeMonkey Snake Game video tutorial series. This gave us a strong foundation to work off of while offering support while we learned the ins and outs of Unity and C# scripting. The next way that we managed this was by learning from each other, and this was probably the most valuable resource that we had. Our project group chat was often a flurry of communicating technical issues and or struggles that we were facing, which was always met with support from the rest of the team. We frequently met up in person to help troubleshoot technical issues while facing the new environment together. And the third way that we navigated this was through the use of AI tools. Sometimes we encountered problems linking our Unity to GitHub. When it came to those problems, we utilized every resource we could, including AI, since we were relatively new to using GitHub as a version control system in a project setting. I know that I personally also used AI tools to write some of the test cases since we were also unfamiliar with the testing framework. And the second challenge that I'll go over is related to this feature, the timer. The problem with the timer was that we wanted our timer to be able to remember, quote unquote, a set split, as you saw in the demo, and then as it flipped back and forth, listening to that timer, and then resetting it in ordinance with the split. So this was challenging. How did we do it? First, we had to understand the problem and identify where we were going wrong. We discovered the issue of timer continuity in two places: when restarting the game and after death, and when switching screens after the timer was set. Like, if the countdown goes to 0, switches to their screen, there would be a problem. We noticed that on death, the timer would reset. Additionally, we noticed that the timer would seem to forget its setup after the first scene switch. In both of these cases, a Unity scene containing the timer element was being loaded, which gave us a hint as to how to solve the problem. So through investigation, we realized that reloading the scenes was meaning that since we had the timer class connected to multiple Unity elements in these different game scenes, or different scenes, it was creating multiple instances of timer. So we would set the split on one instance of timer, but then, oh no, we reloaded it, it's a new instance now. So, yes. This would erase the setup which was stored on the previous instance. The solution then to this was to have only one timer instance at a time, instantiated at the main menu and nowhere else, and bind it to the text elements through a binder class rather than treating each countdown as its own timer. And then, of course, we had to playtest and bug fix, since it wasn't perfect yet. Through playtesting, we found that if a user exited the study timer scene, there would be an issue of the timer not resetting the next time the user selected play. Like, it would pick up back at what the time was left on the study timer. In other words, our timer was too continuous. The fix was simple. We just needed to adjust the function that begins the timer to reset the time remaining unconditionally, instead of checking if the remaining time was 0 first. And with those two challenges covered, that is the end of our presentation. Thank you so much for your time and mentorship throughout the course of this class.